Hello, champions. Welcome to Coach Calculus, where mathematics stops being a problem and starts becoming your superpower. If you are ready to make number bow to you, smash that subscribe button, like this video, and let's dive in together. So, looking at the problem before us, you can observe here that we have a problem which is on the topic set. Set. Remember, the definition of set says that a set is a well-defined collection of items. So in this question, we'll be looking at this problem before us here. This particular problem. It says if this is notation for universal set. The universal set. Now, if the universal set is equal to x such that 1 is less than or equal to x and x is less than or equal to 15, and its subsets p and q are p is a set of even numbers and q is a set of multiples of 3, then the problem we're asked to resolve here is draw a Venn diagram to show this information and hence find the following. A says we should find the complement of Q. B says we should find P union Q. C says we should find P intercede Q. D says we should find complement of P. And finally E, find the complement of P union Q. Now, without wasting much of our time, let's dive into the calculations. Solutions. Remember they said that the universal set is equal to x such that 1 is less than or equal to x and x is less than or equal to 15. Now this is what we call set notation. Now to bring it out so that you can see all the elements contained in this set, you can see that, remember, 1 is less than x, less than or equal to x, which means 1 is inclusive, and also x is less than or equal to 15. 15 also is inclusive. Therefore, x is a value which range from 1 to 15. So we have the universal set will be written as equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and then 15 and 15. So these are all the elements of the universal set. Also, they said the set P is equal to even numbers. Remember, they are subset of the universal set, even set of even number, which implies that P is a set of all the even numbers that can be found in the universal set, which are the set of the even numbers that can be found in the universal set are, we have 2, 4, 6, 8, 10, 12, and 14. So these are the elements of set P. Also, Q is a set of multiples of 3, which means Starting from 3, and the multiples of 3 are, we have 3, 6, 9, 12 is a multiple of 3, and then 15. So these are the elements of set Q. So these are element of the universal set, element of set P, and then element of set Q. The first thing here is that we were asked to draw the Venn diagram of these sets. Now, to draw the Venn diagram, if we observe this question very well, if we are going to know if the set P and set Q will intersect, that is to if they will lap each other. Observe these two elements. Do they have any elements in common here? Yes, they have elements in common, which are 6 and 12, which means the two sets will overlap each other. So I will draw a circle like this. I'll draw a circle like this. I'll draw a circle like this, and then I'll also draw another circle that will overlap on the first circle. Will overlap on the first circle. Now, in set theorem, we normally draw a rectangle to represent the universal set. This is to represent the universal set. The universal set. Okay, let's say this is set P and this is set Q. Set P and set Q, and this is the symbol for universal sets. Now, the elements they have in common are 6, that is, we have 6, and we also have 6, and we also have 12. These are the elements they have in common. And then the element of set P are 2. We have 2, 4, 6 is here already, 8, 10, 12 is here, and then 14. While the element of set Q are, you have 3, 6 is here already, 9, 12 is here, and then 15. So this is the diagram for the two sets. So under A, we were asked to find the complement of Q, which means the elements in the universal set that are not in the set Q. Elements in the universal set that are not in set Q. They are the elements in set Q are 3, 6, 9, 12, and 15. And the elements in the universal set are from 1 to 15. Now, to get the elements in the universal set that are not in the set Q, you have to eliminate the elements in the set Q and then write out the ones that are not there inside. So the complement of Q are, we have 1, 1 is in the universal set, but it is not in set Q. 2, 4, 5, 7, 8, 10, 11, 13, and 4 and 14. So these are all the elements in the universal set that are not in set Q. We call them the complement of set Q. Then B asks us to find P union Q. P union Q, which is equivalent to now the element of set P. Now what does P union Q means? It simply means that we were to arrange the numbers from the lowest to the highest using the combination of the two sets. Now doing this, we can see that the lowest element can be found in set P, which is 2. Then followed by the next number after 2 is 3, can be found in the set Q, which is 3. And then the next can be found in set P, which is 4. There is no 5 in any of the two sets. 6 can be found in set P, 6. And then followed by 8, 9, 10, 12, 14, and 15. So arranging the element in order of ascending order from the lowest to the highest using the two sets. That's what we call the union of two sets. Arranging the elements in the two sets in one from the lowest to the highest. How is it? Then C, we are asked to find P intercede Q. P intercedes Q. And what does that mean? It means we should find the element that can be found in set P and also in set Q. That's the meaning of intersection. This is symbol for intersection. So the elements that can be found in both sets, that are common to both sets, are, if you look at it very well, even from the Venn diagram we drew, you can realize that the element common to both sets are 6 and 12. So the P intercedes Q is 6 and then 12. And D asks us to find the complement of Q. Remember I told you when complement of P. Remember I told you when I was looking for the complement of Q in A, I told you that the elements in the universal set that are not in set Q. So in this one, we'll be looking for the elements in the universal set that are not in set P. The elements in the universal set that are not in set P are, we have 1 is not in P, 3 is not in P, 5 is not in P, 7 is not there, 9 is not there, 11 is not there, 13 is not there, and also 15. So these are all the numbers that cannot be found in set P. We call them the complement of P. So this is the answer to the complement of P. And then finally, the last one, we are asked to find complement of P union Q. Complement of P union Q. And what does that mean? It means find the elements that are not in P union Q. Remember, we've already calculated P union Q here. Now, comparing this to the universal set, which of these elements here are not in the which of the elements in the universal set cannot be found here? We can see that from comparing the universal set and this set, we can see that 1 is not there, 5 is not there, 7 is not there, 11 also is not there, and 13. These are the elements in the universal set that cannot be found in this P union Q. We call it complement of P union Q. So these are the answers to the questions. Remember, every math genius was once a beginner who didn't quit. Keep practicing, keep believing, and stay tuned by subscribing to Coach Calculus. The world must see the genius in you. Have a nice day. Thank you.